Welcome to Session 10.0, Entertainment and Office Equipment. This EMSI training section covers energy basics of entertainment and office equipment. Your presenter is Rick Mitchell. This presentation looks at the types of equipment used in the entertainment and office sector, what standby power is, Energy Star and MEPS ratings, power management, and some example calculations. Many of the conveniences we have come to expect in our modern lives rely on one, if not a series of appliances. Computer systems run the way we do business, and in some cases TVs can run the way we live. We boil water for our coffees, protect ourselves and our businesses with alarms and security systems, and even print airline tickets if we're lucky. But all of these services come at a cost. Types of equipment. There are a few different types of electrical equipment used in households and small to medium enterprises that aren't covered under previous sessions. These can be generally categorized into administration and computers, kitchen appliances, audio-visual, and other equipment. The majority of appliances used in the business and commercial sector are computers, printers, scanners, and phones. Each of these and the peripherals that come with them use additional power while in standby mode and can account for up to 15% of total business energy expenditure. There are two types of commonly used computers. Desktops are far more power hungry than laptops, requiring consuming UPS systems where loss of power to the desktop is too costly. However, they have their advantages in other areas. They are more powerful than laptops and are easily upgradable when it comes to hard drives, RAM, and graphics cards. Laptops have advantages of their own. They require 50 to 90% less power, take up less space on the desk, are portable, and can obviously run on battery during a power outage. The average lifetime of a computer can be anywhere from 2 to 5 years, depending on the purpose of the computer and how often upgrades are required, for instance, to cope with running newer software. There are two common types of printers used in households and small to medium enterprises. Inkjet printers use much less energy than laser printers, however usually it costs more to print and results in poorer quality print. Most companies and businesses will use a laser printer. These printers consume a large amount of power in standby mode. Therefore, measures should be taken to have as few as possible plugged in at one time. Also, printing in one batch will save energy by reducing the need for the printer rolls to heat up and cool down each time something is printed. Measures should also be taken to reduce the need for printing to paper, which will see a direct reduction in energy consumption. Laminators can consume a large amount of energy if used frequently or left on. Some laminators have temperature settings which allow you to use it at a lower temperature, which can save energy. Also, the more expensive units have an auto-off feature, which will turn the unit off after 30 minutes of inactivity. This is still very wasteful, and so it is best practice to switch the laminator off after it is used, although this feature is great for the occasional time that it is accidentally left on. Another great initiative is to laminate in batches rather than individual pages throughout the day. A laminator in active standby mode will consume 820 watts on average. There are many savings to be achieved in kitchens. Having sufficient airspace around the fridge freezer, using an instant hot water appliance so you can only boil what you need, and switching off the coffee machine at the wall when not in use are just a few. Please refer back to the food preparation session if you would like more specific information relating to kitchen appliances. Audio-visual appliances include televisions ranging from cathode ray tube, or CRT, to LCD and LED, plasma, and projection televisions, media playing devices such as DVD players, digital set-top boxes, and radios and speaker systems. Within the business sector, a TV may be used for a variety of functions, including displaying presentations from a computer for a meeting, displaying advertising at a reception counter, or in a shopping center, displaying a menu at a restaurant, or simply for displaying a TV channel for waiting customers or for workers in a lunchroom. Most homes nowadays also have game consoles installed. Televisions are widely used in households and enterprises, and it's important to note consumption values and energy-saving initiatives. Energy consumption of televisions depend on three main factors: screen size, technology type, and picture brightness. Televisions in Australia are also given an Energy Star and a MEPS rating, which will be discussed shortly. There are generally 4 types of televisions available nowadays. Here is a quick overview. CRT televisions, or cathode ray tube televisions, are the classic older type of television models. They use a heated filament, or a cathode, which is in a vacuum inside a glass tube. When current passes through the filament, it heats the cathode, producing a ray of electrons that strike a phosphor-coated screen to emit visible light. LCD televisions use a liquid crystal display, where a liquid is essentially sandwiched between two plates and changes when current passes through it. LCDs need a light behind them as they do not emit a light of their own. Standard LCD screens use a cold cathode fluorescent lamp, or a CCFL, which is a series of tubes laid horizontally behind the screen. LED televisions are essentially LCD televisions. However, they use light-emitting diodes, or LEDs, to light the screen instead of the CCFL. Plasma televisions use tiny gas plasma cells, which are then charged by precise electrical voltages to create an image. Plasma televisions draw up to 3 times the amount of energy that an LED or LCD does. Thus, if a new TV is purchased, LED or LCD would be the best choice in terms of energy consumption. These also have the added benefit of not burning a static image into the screen. Televisions do not consume a huge amount of power in passive standby mode, amounting to 5 to 10 watts. However, if you combine this with accessories such as DVD players and set-top boxes, then the cost of leaving them running in standby starts to add up. TV settings can be adjusted to improve power consumption by up to 50%. It is not unusual to come across game consoles in a home energy audit. The most common of these include PS3, Wii, and Xbox systems. Consoles vary in power consumption, with the PS3 having the higher operating consumption of 190 watts and the lower standby power at 0.5 watts. Naturally, the older consoles consume a higher amount of power. Media players, such as DVD, Blu-ray players, and video cassette recorders, have a varying power consumption from 20 to 35 watts, with older VCR models up to 50 watts. Standby power consumption ranges from 1 to 7 watts. Clock radios and speakers have a power consumption of up to 50 watts, depending on the size of the system. Newer models have a low standby power consumption between 1 and 2 watts. The final type of equipment are those that must remain on 24 hours a day, 7 days a week, such as security systems and IT equipment. Because of this, energy savings is generally limited to upgrading technology to more efficient models, and regular maintenance to make sure the equipment is staying cool and not running fans at excessive speeds. More examples of continual operation equipment include security cameras, monitors, alarms, routers, servers, UPS, and answering machines. Entertainment and office equipment theory. As with food preparation and cleaning appliances, the total power consumption of an appliance can easily be calculated by multiplying the power consumption, be it either operating, active standby, or passive standby power, by its respective time of use. If all 3 types are present, then the addition of these will equal to total power consumption of an appliance. Now let's look at reducing the power consumption of an appliance. Power consumption is essentially influenced by the standby power, the different types of technologies available for that appliance, and the appliance Energy Star and MEPS rating. Let's look at these more closely. As covered previously, standby power is energy used by an electrical device while connected to power but not in operation. Passive standby is where the appliance is in lowest power consuming mode and can be detected by an LED light, clock, or where the device is waiting to be switched on by remote. Active standby is where the appliance is on but not performing its main function. A device is usually only completely off when it is switched off at the wall, as devices can still consume very small amounts of power even when they are switched off at the device's power switch, if it has one. Standby data is usually obtainable from the appliance manufacturer. You can measure the power usage of an appliance using a plug-in power meter. Plug-in power meters are a useful tool for an assessor to carry as they allow you to spot measure appliance energy use while auditing. As an initiative, they are also good for making clients aware of their energy use by displaying in real time the consumption of particular appliances. There are also many products that can be purchased that have a very low standby power consumption. Controllers have now been developed to make it easier for people to manage the standby power of appliances by using a remote control or extended switch to turn off devices, rather than having to switch them off in an awkward place on the wall, such as under a desk or behind a TV. This table shows examples of standby power values for selected equipment. As you can see, the big offenders in standby power are CRT monitors, photocopiers, laser printers, televisions, and laminators. However, large power values do not always mean a large energy bill at the end of the quarter. The difference lies in how long each item is left on. For instance, a laminator is not usually left on for a long period of time, whereas many workers may leave their computers on for long periods of time. Use this table as a reference for standby power values. However, experience will give the best indication of whether an appliance is consuming more or less than usual. The type of technology will also influence the power consumption. Using older technologies, cathode ray tube televisions for example, will consume more power than an LCD television. As technology develops, improvements are made in the way the appliance consumes power, often leading to a reduction in intensity. More recent technologies usually have a better availability of spare parts too. It is essential that when selecting an appliance, one selects the most efficient and cost-effective technology that will meet their operational and comfort needs. Even though more recent technologies often represent higher capital costs, the long-term savings are made in the energy reduction and energy cost savings. Energy Star was created by the US Environmental Protection Agency in 1992 and has now been adopted by several countries around the world, including Australia. It was created to reduce greenhouse gas emissions and other pollutants caused by the inefficient use of energy. The rating makes it easy for consumers to identify and purchase energy-efficient products that offer savings on energy bills without sacrificing performance, features, or comfort. A product receives the Energy Star rating if it conforms to a series of requirements specific for that product, such as requiring TVs to have an option for automatic brightness control. There are no degrees of rating in the Energy Star rating scheme. Either a product carries the badge or it doesn't. The Minimum Energy Performance Standards, or MEPS as they are commonly known, are a set of standards that specify the minimum energy requirements of appliances imported to Australia and New Zealand. All televisions imported into Australia after the 1st of October 2009 are required to display an approved energy label, which is based on the minimum energy performance standards set by Australia. At the moment, the minimum level is Tier 1 MEPS, which is equal to 1-star rating. However, in October 2012, the new minimum will be Tier 2 MEPS, which is equivalent to 4 stars. Reducing the total time that an appliance is in use or on standby mode will significantly reduce its power consumption. The time of use includes the operating time and active and passive standby times. The reduction of use time is influenced by the power management techniques as well as power management devices installed in the household or building. Power management focuses around reducing the energy use of appliances or equipment, using automated or non-invasive processes and technologies, as well as improving behavioral patterns and consumer habits. Change in user behavioral patterns includes encouraging them to be environmentally conscious of the impacts of energy wastage, encourage building occupants to turn off all unnecessary light when the building is empty, or lighting where a room is not in use, and encouraging users to turn off appliances when not in use or unplug them completely. Encouraging consumers to purchase newer technologies will create a more energy-conscious user. It takes patience and discipline to implement these habits in a workplace or at home, but the rewards are worth it in the end, not only financially, but also environmentally. Regardless of the type of appliance being used, it is recommended that the power management settings are set to a reasonable level. For example, changing the display setting of a laptop to dim after 2 minutes of inactivity, setting the display to go to sleep after 5 minutes, and putting the computer to sleep after 15 minutes of inactivity. What the appliance is used for and how it is used will determine what time values should be chosen for the settings. Using power management in this way can save up to 30 to 40% on energy consumption. In some computers, there are advanced settings that can allow for processing power to be reduced depending on the user usage patterns. Other suggestions are adjusting the contrast, backlight, and brightness in monitors or televisions. Power management devices are designed to reduce overall energy consumption, prolong battery life for portable systems, or reduce cooling requirements of appliances. Timer switches can be installed to switch off appliances after a certain amount of inactivity. Motion sensors in buildings can also be set to turn off equipment after an activity. Power boards are capable of managing slave appliances to a master appliance. For example, a television will be the master appliance, while a DVD player or a game console would be the slave appliance. When the television is turned off, the power board will turn off the slave automatically. Live metering, as discussed previously, is a useful tool to manage and illustrate power use of a building or an appliance, making it visible to users. A few example scenarios. This example shows how to calculate savings from reducing standby power. It's simply a matter of determining the power saving and how many hours a year that saving in power is made. Then this can be multiplied by the electricity rate to give the savings per annum. Question 1. You have been asked to calculate the total running cost of 12 desktop computers in an office. Assuming that the office is open from 9 to 5, Monday to Friday, for 50 weeks, accounting for 1 hour of active standby for lunch break, and the rest of the time they are left in sleep mode, passive standby, what is the total cost of operating these computers? Assume no wattage is consumed when appliances are turned off. The maximum operating power consumed by the PCs is 250 watts and the 17-inch monitor is 22 watts. Base calculations off average standby power values. The electricity rate is equal 24 cents per kilowatt hour. Using the table in section 2, we can obtain the passive and active standby power consumption for the PCs and the 17-inch monitors. Using the table shown previously, we obtain the active and passive standby powers. Adding these values for the respective category and multiplying them to the quantity of computers, we obtain the respective totals. The total operating power consumption is 3,264 watts. The total active power consumption is 1,063.2 watts. The total passive power consumption is 285.6 watts. Secondly, we calculate the total amount of time of use for each session. We obtain a total operating time of 35 hours a week, a total active standby time of 5 hours a week, and a total passive standby time of 128 hours a week. The total energy will be the addition of power multiplied to its respective time of use, all multiplied by the 50 weeks. The total is 7,805.64 kilowatt hours per annum. The total cost of operating the 12 desktop computers would be $1,874 per annum. Question 2. Using the information from the previous question and answers, what would be the total cost saving if the computers were turned off at the end of a working day? If the computers are only turned on during working days, this means that no passive standby occurs. The amount of power consumed during passive standby will be equal to the passive power consumption multiplied by the hours of use multiplied by the amount of 50 weeks. The total power will be 1,827.8 kilowatt hours per annum. The total cost saving will be just under $439 a year. To continue with presentations, please select Energy Session 11.0 Lighting Theory from the navigation bar at right. To complete the assessment for this presentation, please select Tutorial 10.0 Entertainment and Office Equipment.